Hi guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Yes guys, so we are live into the session, the next class, and also welcome to the GATE AIMERS 2022 series. As you know, I started with some sessions of control system. So important topics of important subjects are being discussed in this series. The topics which are more frequently asked, the topics where you need some practice. Accordingly, we have selected the topic. So the next topic in the control systems is the gain margin and the phase margin, right? Because we were discussing about Nyquist and Bode's in the past 2-3 classes. So let us better go in the gain margin and phase margin now. Wrap up that particular discussion regarding to the relative stability and frequency domain analysis. Good evening, Srinath. Good evening, Upendra. Very good evening, all. Yeah, let's start the gain margin and the phase margin session. Okay, to start off, if somebody new to my session, this is a brief intro about me. This is your mentor and educator Rakesh. I've secured All India rank 9th, the GATE, completed my masters from the Indian Institute of Science, Bangalore, and it's been more than 11 years training students, having trained more than 50,000 students in my journey. Yes, students very late in joining today. What's it, guys? Tired, exhausted, end tak aate people get exhausted. Is it the case? All the champions, is it the case becoming with you? Good evening, Swapan. Right, itna jaldi thak jaoge, abhi to gate mein still there are 2.5 months left. So we need to maintain the energy, right? And this is, let me tell you that this is the star faculty team of BYJU'S Exam Prep, Electronics and Communication, the best in the nation, All India rank, best digits in the GATE, in the ESE, the MTech from the best institutes, highly experienced, like some faculty you can see more than 15-18 plus years of experience. And what are the different batches available on the BYJU'S Exam Prep right now? The Vision GATE, a course exclusively for GATE 2022, the Rank Up course, so those who are done with the syllabus and they want the practice and revision and very good variety of questions, you can enroll into the Rank Up GATE course. And for those who aim to appear in the GATE or ESE next year, that is 2023, so dedicated full-fledged course, that is the Vision 2023, also live for you. Right. Good evening, Shri Guru, Shiva, Ripakshi, Juhi, very good evening all. So let us get started with the questions, guys. What do you want? Don't we want this session? Aaj mujhe bahut slow lag raha hai. Let's wait. The students should join quickly. A unity feedback control system has the open loop transfer function given to you. GSHS is equal to 16 is divided by S plus 2, S plus 4. Find the phase crossover frequency and the gain margin. Now, we'll also see the formula. We will revise it up, etc. We'll do the revision as well. Okay, but yeah, one thing we need to ensure here is, just one second. One thing we need to ensure here is key formulas and some relation with the Nyquist plots that we have seen should be discussed simultaneously. Okay, come on guys, get the answer for this one quickly. Come on, get. Just a second. This case, is it fine now? It was looping for a moment, I think. Is it fine now? Now fine? Okay. Chalo guys, so yeah, that's a question on screen. A unity feedback control system has the open loop transfer function. Okay, so I think by this time you might have solved the question also. So why I'm starting with this question? Because this is once again the very expected case where the GSHS has been given to you. The GSHS has been given to you as 1 upon S, 1 plus ST1, 1 plus ST2 form. Okay, so let's use the results for that directly. Let's make it into the time constant form first of all. So we get 1 plus S by 2 and then taking the 4 common, so 1 plus S by 4. So I want to make it into the time constant form, and 16 by 8 is equal to 2, and this is equal to 2 by S, 1 plus S by 2, 1 plus S by 4. 2 by S, 1 plus S by 2, 1 plus S by 4. That is what is the GSHS. 2 upon S, 1 plus S by 2, 1 plus S by 4. Everybody. Okay. Now, what is the polar plot for this? I want you to understand this through the polar plot first of all. Some issue is happening again. So the polar plot for this one, 1 upon S, 1 plus ST1, 1 plus ST2 form. So this is one of the very important case in Nyquist plots, in polar plots, in Bode plots, and also in gain margin, phase margin. So that is why first starting with this case. Now what is the phase crossover frequency, guys? The phase crossover frequency is the frequency where this polar plot will intersect the negative real axis. That is what is my omega p. Slight idea about the omega p I also gave you when we were discussing the polar plots and Nyquist plots. So when the polar plot, let's see the definitions also. It is the frequency at which the Nyquist plot intersects the negative real axis. And whenever the Nyquist plot is intersecting the negative real axis, what is the phase at that point? What is the angle Gj omega at j omega? That is plus minus 180 degree. That is plus or minus 180 degree, right? So we just have to equate the angle to plus minus 180 degree. This is the general formula for finding omega p. But here, if you see here, this is the polar plot already discussed with us. So what is this frequency at which the plot is plotting the negative x-axis is already known to us, 1 upon under root t1 t2. For this function it is known, not always. For other type of function, I will give you the formula based approach, but this is already known value. Okay, then what is the value of gain margin? What is the value of gain margin? It is the margin by which the gain of a stable system can be increased before it reaches the point of instability or before it tries to go into the unstable region. Okay, and the gain margin is given by 1 upon magnitude at omega p, 1 upon mod Gj omega p at j omega p, or in the decibel it is 20 log 1 by mod Gj omega p at j omega p. Commonly we prefer in the decibel. This is a by default unit. Otherwise this is the absolute formula, 1 upon magnitude at omega p. Achha. What about the phase margin? Let us define both and then start solving the question. So gain crossover frequency, it is the frequency at which the Nyquist plot intersects the unit circle. And whenever the Nyquist plot is intersecting the unit circle, so unit circle has a radius equal to 1. That means the magnitude, okay, of the frequency response Gj omega at j omega equal to 1. So how to find out the gain crossover frequency? Mod Gj omega at j omega equal to 1. Okay, we see the formula ki baat kar rahe hain. And then what is the phase margin? It is the margin by which the phase of a stable system can be changed before it reaches the point of instability, and it is given by the formula 180 degree plus angle Gj omega p at j omega p. 2-3 important points to be noted, right? Ki whenever a system is stable, okay, whenever a system is stable, both the gain margin and phase margin will be positive. Positive means gain margin in decibels and phase margin in degrees, the proper units. So gain margin is positive and phase margin is positive. For unstable system, both are negative. And for marginally stable system, both are equal to 0. That means either both are of the same sign, that is positive, or either they are negative. They will not be of different sign. You will never find that the gain margin positive and the phase margin negative. Nahi, aisa aap nahi dekhoge. Either they are both positive or both negative. Or if they are both equal to 0, then the system is marginally stable. Some more relations with respect to the crossover frequencies. Whenever omega g less than omega p, see, try to remember like this. G and P in the alphabetical order. G comes first, alphabet sequence maybe G comes before P, na? So whenever G comes before P, whenever they follow the alphabetical sequence, system will be stable. Whenever omega G greater than omega P, reverse, unstable. If they are equal, marginally stable. If they are the equal, marginally stable, right? So for this particular function, 1 upon S, 1 plus ST1, 1 plus ST2, we already know the answer. The omega p is 1 upon root t1 t2. So let's place down this value. So what is the omega p? 1 upon under root of, what are the time constants? 1 by 2 and 1 by 4. 1 by 2, 1 by 4. So 1 upon 1 by root 8, basically root 8 or 2 root 2 radian per second. So what is the phase crossover frequency? 2 root 2 radian per second. Now what is the gain margin? What is the gain margin? For gain margin, I need the magnitude of the function at this point. I need the magnitude of the function at this point. And what is the magnitude of the function at this point? See, what was this magnitude, guys? Try to recall everybody. Ye magnitude kitna tha? This was given by the formula T1 T2 divided by T1 plus T2 when the numerator was 1. 1 upon 1 plus ST1, 1 plus ST2. But this is numerator amplified by 2, magnitude amplified by 2. So 2 T1 T2 upon T1 plus T2 will be written here. So this should be equal to how much? 2 into T1 T2 divided by T1 plus T2, so this should be twice of 1 by 8 or you get 6 by 8, so twice of 1 by 6, that is 1/3. So what is this value? This is known as 1 by 3, right? Now see what is the gain margin. Okay, now with respect to see this, what is the value of gain margin? Gain margin is known as 1 upon magnitude at phase crossover frequency, that is 1 upon 1 by 3, that is equal to 3. In the decibel, it is equal to 20 log of 3. In the decibel, it will be equal to the 20 log 3, right? Whose approximate value will turn out to be, in decibel, somewhere around 9.5 decibel. You can check it up, somewhere around 9.5 decibel, right? Okay, 9.5 decibel will be the answer for this, everybody. Okay. Now see, try to understand one more thing here. The magnitude at omega p is 1 by 3. Why the gain margin is 3? What is the meaning of this gain margin equal to 3? This gain margin simply says that the current gain of the system is 1 by 3 when it crosses the negative x-axis. If I multiply it by 3, what happened? Okay, what happens? When you multiply 1 by 3 by 3, the gain will become 1. Okay, the gain will become 1. That means the Nyquist plot will shift and it will now going to pass through the -1, 0. It is now going to pass through -1, 0. What happens if you increase the gain beyond this? इससे ज़्यादा increase किया, then what will happen? If you increase it beyond this, then it is going to encircle -1, 0 after you take the closing. This is only the polar plot. Then I take the mirror image and then you close like always. So you will find that -1, 0 will be encircled 2 times in the clockwise direction. Apply the formula of n equal to p minus z, which we were applying in the last class. You will get z equal to 2, right? Z equal to 2, isn't it? And system becomes unstable. So if you increase the gain of the system more than 3 times, system becomes unstable. So what is the margin in your hand? आपके हाथ में कितना available margin है? You can amplify the gain of the system maximum by 3 times, not more than that. If you increase more than that, system becomes unstable. Okay, system becomes unstable. That is what is the concept of basically gain margin, the simple concept. The margin by which the gain of a system can be amplified before it becomes unstable. Okay, so when I say gain margin is 3, so you can increase the gain up to the 3. 3 is the worst case. 3 पे भी marginally stable होगा. ठीक है, 3 a little less than 3. This much margin you have. If you want, you can amplify the gain of the system. You can get better gains, but not beyond that. Beyond that, unstable हो जाएगा. Unstable system is practically of no use. ये तो हमको पता ही है, right? That is what it is. चलो, let's move ahead then. Okay, let's move ahead. So with this concept, once again on the picture, one conceptual question. ये सभी को आंसर करना है easily. Conceptual question. One conceptual question. The polar plot of a transfer function is given below in the figure. What is the gain margin of the system? What is the gain margin? Very simple question. Decibel में पूछा है. So this is what is omega p, right? This is what is omega p. This is given to you. ये omega p है, ये given है. Okay, but what is the magnitude at omega p? 0.666. So what is the gain margin? 1 upon 0.666. ये हो गया absolute gain margin. Okay, this is known as the absolute gain margin. ठीक है, 1 upon 0.666 or basically 1.5. It will become 1 upon 2 by 3. So 3 by 2, okay, 1.5. That is the gain margin. But in decibel, it becomes 20 log of 1.5. Calculate this value. Chalo, let us calculate this one quickly. How much it is turning out to be. Virtual calculators आप use करेंगे only. Turning out to be 3.52 in decibel. 3.52, or that is approximately option number B is the correct option. Option number B is the correct option. That's it. Okay, so omega p is 1 by root 2. So this is a direct visual question. Okay, very one simple calculation you have to complete. Yes, correct. Komal, Srinath, Dipakshi, Swapan, correct answer. ठीक है, बढ़िया. Now let's take one more conceptual question here. The pure concept, as per the basic definition and basic idea, whether you know about the gain margin and phase margin or not. क्या बोलेंगे? The frequency response of a linear system is provided in the tabular form below. Right? What is the gain margin and phase margin? So guys, gain margin is calculated at, first question is gain margin, and gain margin is calculated at omega p. So in this table, there is no frequency given. Okay, but the gain and phase information is given. What is omega p? It is the frequency at which phase becomes minus 180. Phase crossover, minus 180. So I don't know what is that frequency, but I am able to see that value in this table. I am able to see that value in the table, right? So this is corresponding to omega p. Okay, so then what is the gain margin? What is the gain margin in decibel? Options decibel when, 20 log 1 over magnitude at that frequency. What was the final formula? 20 log 1 upon magnitude at that frequency. What is the magnitude at that frequency? 0.5 है ना, use कर लेंगे, use this magnitude. At that frequency, which is unknown, but corresponding to this phase, the magnitude is 0.5. Okay, so this becomes 20 log 1 upon 0.5, that is 2. 20 log 2 is equal to 6 decibel approximately. Right? Right? Now, if it is 6 dB, we will come to that also, Juhi. If it is 6 dB, ध्यान देना, what is the conclusion that I can directly say? Gain margin is positive, 6 decibel. Right? So phase margin is also positive. Confirm hai. Confirm. Both will be of same sign. So no need to calculate phase margin. Agar gain margin positive 6 dB hai, so it cannot be minus 30 degree as the phase margin. Option number A, finish. Okay, that is by logic. But you say, sir, I want to calculate phase margin. Kar sakte hai. We'll calculate the phase margin also. Don't worry. Right. So if I actually want to calculate phase margin, we know that it is calculated at gain crossover frequency. Now, sir, what is the gain crossover frequency? The frequency at which, the gain of the system, the magnitude is 1. So this is what is the magnitude equal to 1. Look into this. This corresponds to gain crossover frequency. Then what is the phase margin formula? Then what is the phase margin formula? The formula for phase margin is known as the 180 degree plus angle of Gj omega g Hj omega g. 180 degree plus phase at that frequency. So it is 180 degree plus minus of 150 degree and the answer is 30 degree. As already we have matched the option, but this is how we can relate both. 100% Srinath, yes. Okay, chalo, cool. Next one, guys, moving ahead to the next question. Now this is a question where we'll properly use the formula. Is this of the form 1 upon S, 1 plus ST1, 1 plus ST2? No. Given any other GSHS, to find out the gain margin or phase margin, we'll apply the basic formulas. So Gj omega is given to you, 1 upon J omega plus 1, calculate the gain margin. But for the gain margin, everybody knows we need the omega p first of all. We need the omega p, ye confirm hai. So we need to start with omega p. Okay, so omega p ke liye I need the angle. What is the angle Gj omega, Hj omega? The angle part, the phase part. So what is the phase? Numerator is positive real number. So denominator x plus jy, phase is tan inverse y by x, tan inverse omega. But how many terms? 3 terms. So tan inverse omega, tan inverse omega, tan inverse omega 3 times. Okay, ye ho gaya minus 3 tan inverse omega. Minus 3 tan inverse omega. Okay. Because gain crossover frequency is at the frequency at which the magnitude is 1. If you need to understand why, if you want a derivation, so long time back मैंने derivation वाले sessions भी लिए हुए हैं, so you can follow that. How do we derive gain margin, phase margin, and why do we write these formulas? Okay, right now I'm not discussing it. इतना time नहीं है because this is practice based session right now. Juhi. Okay, so what is the total phase? Minus 3 tan inverse omega, and at the omega p, what is this angle? It should be minus 180 degree, plus or minus, but yeah, minus hai, so let's maintain minus only. So minus 3 tan inverse omega p is minus 180 degree, which means that the tan inverse omega p is 60 degree. 3 cancel kar diya. So what is the value of omega p now coming up? Tan of 60 degree, and the tan 60 degree is root 3. Okay. Root 3. The omega p is equal to root 3. Now, what is the magnitude at omega p? Okay, so magnitude at omega p, that is mod Gj omega p Hj omega p. देखो ना कितना होगा magnitude? 1 upon under root x plus jy. Magnitude is x plus jy magnitude is root over x square plus y square, but then it is coming 3 times, cubic term hai, so magnitude also becoming the cube, right? So what is this? Put down the value of omega p, and the omega p value is root 3, so omega p square is 3. So under root, oh sorry, ये cube है. Under root of 4 is 2, and 1 upon 2 cube is 8. So 1 upon 8 is the magnitude. So what is the gain margin? Decibel में पूछा है. So what is the gain margin? Final answer 20 log 1 upon magnitude at omega p, and the magnitude at omega p is 1 upon 8. So 1 upon 8 becomes 8. So this should be 20 log 8, which will nearly come up as 18 decibel. 20 log 2 is 6 dB, so 20 log 8 will be nearly 18 dB, right? Right? 18 dB. Chalo. Which formula you say, Juhi? Correct answer is 18 dB. The gain margin for the system is 18 decibel. Everybody, okay? Cool. Moving ahead to the next question. The open loop transfer function of a system is given to you with the exponential term, the transportation lag term, the time delay element. This is known as the time, we all know what is e power minus st. What is the e power minus st? Is known as time delay element, or a transportation lag term. ठीक है. What is the gain margin of this system? Questions involving exponential. Juhi, that's what I told. Whenever the function is 1 upon s, 1 plus st1, 1 plus st2. 1 upon s, 1 plus st1, 1 plus st2. Then the omega p is 1 upon root t1, t2. When that type of function is there. Otherwise, the basic formula. Okay. Chaliye. So, gain margin. Again, gain margin ke liye, every time we need the omega p. What is the omega p? Right. What is the omega p? We need to start with omega p. So, what is the gj omega? Have a look at this function. So, gj omega is e power minus 0.1 j omega divided by j omega. So, what is the angle gj omega? E power j theta. The face is theta. E power j theta is theta, face is theta. Minus, now देखो यहाँ पे एक mistake हो सकता है. क्या possible mistake है? Minus commonly we write down 90 degree. But when you write down e power theta, e power j theta में theta is by default in radian. Radian and degree साथ में नहीं चलेंगे. So either convert this to degree or write down 90 degree as pi by 2. Both in radians. But not required, Srinath. Okay. So this is the angle expression. Now for omega p, right? At omega equal to omega p, we need this phase equal to minus 180 degree or minus pi. Everything should be radian. So minus 0.1 omega p minus pi by 2 is minus pi. So basically 0.1 omega p is equal to pi minus pi by 2. Pi minus pi by 2 will be pi by 2. So what is the value of omega p? ये चला जाएगा 10 उधर, 10 pi by 2, that will be equal to 5 pi. The phase crossover frequency is 5 pi. Now what is the gain margin? So what is the gain margin? So what is the modulus of gj omega? See, इसका modulus भी यहाँ पे लिख देते हैं. So what is the mod gj omega? Every time, what is the mod of e power j theta is 1. J omega mod is omega, right? E power j theta magnitude is 1. Under root cos square theta plus sin square theta. So what is the magnitude? Right. At omega p, which is 5 pi, what is the magnitude? Mod of gj omega p. That magnitude is 1 by omega, that is 1 upon 5 pi. Right. So what is the gain margin then? Decibel में बोला है? Yes, again decibel. So 20 log 1 upon this magnitude. So again, after taking the reciprocal, this is coming up as 5 pi. 20 log 5 pi is the answer. Let's calculate and write down the final numerical answer type value. So after taking the log, 23.9. What is the gain margin for this system? 23.9 decibels. 23.9 decibels is the answer, everybody. Okay, 23.9 decibel is the correct answer. Okay, chalo, clear. Next question, one more question based on the transportation lag, time delay element. Because this is the transfer function which introduces the time delay, yt equal to x of t minus t. You can think with the Laplace transform. Consider the following feedback control system shown below. What is the maximum value of td, the time delay term, for stability? The best methods of solving the exponential. See, Raut-Hurwitz are for polynomials. You can approximate this as polynomial if you want to solve by Raut-Hurwitz, but that is just an approximation. The best way of finding the range of t for stability for exponential function should be the phase margin analysis. Phase margin analysis. Achha, why phase margin? Why phase margin? Because see, the time delay element is e power minus st. E power minus st agar gs ho jab bhi, okay, e power minus st jab bhi gs ho, see, let us write down this one here. Whenever the gs is e power minus st, that is the time delay term. What is the gj omega? E power minus j omega t, right? So what is the magnitude of this term as we just discussed right now? What is the magnitude of this is 1. And what is the angle gj omega? What is the phase of this? Phase is minus omega t. Negative omega t. Radians mein. Minus omega t radian. By default it is radians, okay? So if you keep on increasing the value of t, what will happen? It will try to pull the phase of the system in negative direction. It will try to reduce the phase of the system, which will reduce the phase margin. So if you keep on increasing t, the phase margin decreases. So there comes an upper limit on t, okay, where the phase margin becomes 0, marginally stable. If you increase t beyond it, system is unstable. That will decide the maximum value. So why phase margin? Because gain is constant. So it will affect the phase margin part actually. So we will try to solve the problem by phase margin. So what is the GS here? What is the GS here? It is 3 e raised to the power minus std. Td is the time delay divided by s. Okay, or rather what is the gj omega part? 3 e raised to the power minus j omega td divided by j omega. What is the angle part for this one and what is the magnitude part? Pehle formula likh lete. What is the angle gj omega? Is 3 is constant minus omega td, e power j theta phase is theta, then divide by j omega. So don't write 90 degree, write pi by 2. Radian. What is the magnitude of this? Magnitude expression 3 into 1 divided by omega. So that is simply 3 by omega. Now I am asking you to solve by phase margin, and for phase margin I need the omega g first of all, right? Omega g. So what is omega g? For omega g, the magnitude, omega g, the gain crossover frequency, is the frequency at which the magnitude equated to 1. Yahi formula dekha na humne? Magnitude equated to 1. So 3 divided by omega g. 3 upon omega g is 1. So you get the gain crossover frequency. You get the gain crossover frequency, guys, which is equal to the 3. You get the gain crossover frequency which is equal to the 3. Okay. Then what is the angle at omega g? What is angle gj omega g? Minus omega td minus pi by 2. That is minus omega g td minus pi by 2. Omega g ka value 3 hai, to minus 3 td minus pi by 2. So eventually what is the phase margin? (180° plus angle gj omega g, 180° plus minus 3 td, sorry 180 यहाँ पे भी नहीं लिखते, let's write down pi, radian. Finally we can convert to degree if required. So pi minus 3d minus pi by 2. So eventually the phase margin is pi by 2 minus 3t. That is what I am telling you now. If you keep on increasing the value of td, the phase margin will reduce. Okay, so what is the upper limit of td? What is the upper limit of td? For stability, What is the range of TD for stability? That is what is the question, na? What is the range of TD for stability? For stability, we need that phase margin should be positive. Okay, that means pi by 2 minus 3 TD should be positive. That means TD, 3 TD less than pi by 2, so TD less than pi by 6. TD less than pi by 6. TD is less than pi by 6. That means it should be nearly 0.52. TD less than 0.52. So what is the worst case maximum value? We'll take 0.52. What is the maximum value for TD? 0.52, right? Yeah, correct, Srinath. Good evening, Parmesh. Okay, 0.52, the maximum value of the TD. Okay, solved using the concept of phase margin. Question stability ka hai, but whenever, again I repeat, whenever you have the time delay element term, okay, and you want the maximum value of the time delay factor T for stability, use the phase margin method, the best method, the accurate method. Routh-Hurwitz से approximate answer आ जाएगा वहां से भी. You will have to approximate this as, you know, maybe up to quadratic term you can approximate. Because Routh-Hurwitz mein we need polynomial, so you have to make a polynomial approximation of the exponential. Directly Routh-Hurwitz cannot take the exponential. Chalo, cool. Next question. The open loop transfer function of a unity feedback system is given to you. What is the value of K that will result in a phase margin of 45 degree? What is the value of K? The phase margin is given to you of 45 degree. Phase margin is 45 degree. Okay. So first of all, let us write down what is the Gj omega is K 4 plus j omega divided by j omega minus 1 plus s, so minus 1 plus j omega. And I need the angle expression. Good evening, Shabna. I need the angle expression. What is the angle Gj omega? Will become tan inverse omega by 4. Numerator के लिए, denominator के लिए minus 90 degree, right? Then minus tan inverse omega upon minus 1. Tan inverse y by minus x. What is the formula? अब यहाँ पे थोड़ा सा आपको simplify करना है पहले. This is equal to tan inverse omega by 4 minus 90 degree minus tan inverse omega upon minus 1 is known as 180 degree minus tan inverse y by x. 180 degree minus tan inverse omega by 1. अच्छा जी. So what is the final expression for angle now becoming minus 90 minus 180? ये हो गया minus 270 degree plus of tan inverse omega by 4. This is also minus minus plus tan inverse of omega. ठीक है. What is the value of K that will result in the phase margin of 45 degree? Phase margin of 45 degrees required. So what is given to me is a phase margin of 45 degree. Phase margin means 180 degree plus angle Gj omega G is 45 degree. Right? Is 45 degree. So what is the angle Gj omega G should be 45 minus 180 minus 135. ये expression उठा लीजिए. Minus 270 degree plus tan inverse omega by 4, omega G by 4 plus tan inverse of omega G is minus 135 degree. Send the minus 270 on the right hand side. तो कितना हो जाएगा? Tan inverse A plus tan inverse B identity also I will apply. So tan inverse A plus B upon 1 minus AB is 135 degree. 270 minus 135, 135. ठीक है. So basically this is equal to how much? ये हो जाएगा 5 omega G divided by, multiply कर दिया ना 4 से, 4 minus omega G square is equal to tan 135. Second quadrant में tan is negative, तो this is minus 1. Okay, so यहाँ से calculation से पहले omega G आ जाएगा. So 5 omega G is equal to minus 4 plus omega G square. So I get a quadratic equation, omega G square minus 5 omega G minus 4 equal to the 0. Right? Minus 4 here na? This one is minus 4. So what are the roots of this? Okay, you can find out by the quadratic formula. (5.7) and minus 0.7. So what is the value of omega g coming up? 5.7 and minus 0.7. But in the polar plot, frequency can't be negative. We only talk about positive frequency. So what is the omega g finally? Finally, omega g will be 5.7. Discarding the negative one. Okay. Negative wala discard karte hue. Okay. So now, if omega g is 5.7, I don't want omega g, I ultimately want the value of k. So what should be the value of k? Okay, so this is the omega g where magnitude is 1. Right, so now at omega g, which is 5.7, the magnitude of the system should be 1. So dekho, magnitude quickly likhenge, k under root of 4 plus omega square, under root of 4 square plus omega square, divide by magnitude of omega is omega under root of minus 1 square plus omega square. This should be equal to 1. ठीक. So omega g का value place करते हुए k divide by omega g, that is 5.7, and under root के अंदर you have 16 plus 5.7 square upon 1 plus 5.7 square. This should be whole equal to 1. Find out the value of k. Just solve it up and give me the value of k, everybody. Just complete this calculation and write down the value of k. (4.73). Yes. So finally solving, the value of k that is turning out is 4.73. The value of k is 4.73, everybody. Okay. Cool. Done. Okay. The phase margin of a system with the open loop transfer function GSHS equal to 1 minus s upon 1 plus s 2 plus s. Okay. Solve करते जाते हैं साथ में. So what is the gj omega hj omega frequency domain function? 1 minus j omega upon 1 plus j omega 2 plus j omega. Phase margin will first of all start with the omega g, as we all know. That will start with the omega g. Okay, so what is the omega g? And omega g ke liye we will take this magnitude part 1. So what is the magnitude? 1 minus j omega, magnitude is root 1 square plus omega square. Again 1 plus j omega, so magnitude is again square root of 1 square plus omega square. 2 plus j omega, so square root 4 plus omega square equal to 1. But eventually what will happen, 1 minus j omega and 1 plus j omega, they are having the same magnitude. Okay, so what is only left with me is 1 upon 4 plus omega g square. Yeah, 4 plus omega square ka under root is 1. That means what should be 4 plus omega square? That should also be equal to 1. 4 plus omega square is also equal to 1. So what is the value for omega square is minus 3. So what is the solution of omega square equal to minus 3? It will be imaginary and frequency can't be imaginary. So do you have any real solution coming up from here? Do you have any real solution? So this will produce no real grain crossover frequency. There is no real grain crossover frequency, matlab there is no gain crossover frequency. So what should be the phase margin? There is no gain crossover frequency, so what should be the phase margin? I will explain. The system has no real omega g. What is the phase margin of such a system? What is the phase margin of such a system is infinity. Option number D. It is always going to be stable. It is never going to intersect the unit circle. And however you want to rotate the face, जितना rotate करना है polar plot को आप कर दीजिए, जितना भी rotate करना है polar plot को कर दीजिए. It is always going to be within the unit circle. And infinite times phase shift is also allowed. Infinity, right? So we can go into the details of polar plot and sketch it up, but right now not required because I have more questions to discuss. So polar plot के respect में आप सोच के देखिए whatever we discussed earlier, right? A few days back, maybe last month or so, na? Yeah, it will be available, Srinath. ठीक है, infinity. Some important points I should actually tell you. Okay, please make a note that. Please make some special notes. Number one, whenever there is no real gain crossover frequency, then the phase margin is coming up as infinite. Number two, whenever the omega p phase crossover frequency tends to infinity, infinity means that is a diving frequency. Infinity पे we talk about the diving case. Polar plots का class जिनने attend किया, they will be able to understand. Okay, so gain margin will also be infinity. Diving means dive into the origin. So when you are cutting the negative x-axis at origin, what is the magnitude at origin? 0. So what is the gain margin? 1 upon 0, infinity. Decibel में लोगे, then also infinity. Okay. So I'm giving you the conclusions, right? Next, point number 3. Whenever omega p is equal to 0, that is the theta st case, starting case, right? Only thing is, don't, ये एक precaution है, don't touch the GM formula. Don't trust the GM formula. You have to solve by polar plot. You have to solve and understand the gain margin by polar plot only. These are some precautions which the students must know. Presenting a next question here in front of you. Again on the phase margin. The open loop transfer function of a unity negative feedback control system is given to you. Gs equal to k upon s, s plus 3. If the velocity error constant kV is 1.054, what is the phase margin of the system? Calculate the phase margin of the system. Okay. So velocity error coefficient. First of all, what is the value for kV? kV is given by the formula limit of s tending to 0 sgs and limit of s tending to 0 sgs. So s or s will get cancelled and then you put s tending to 0 k by 3. So kV, which is k by 3, is coming out to be 1.054. 1.054. So what is the value of k? It should be into 3 kiya to 3.54 into 3. Okay, so 162. Just check it up. Yeah, that should be 3.162. That is the value of k. And now I need the phase margin of the system. So सबसे पहले हमें चाहिए omega g. Okay, so what is the mod g magnitude? That is mod of gj omega. The mod of gj omega will be k, which is 3.162 is divided by omega square root of omega square plus 9, and this should be equal to 1. Okay. This should be equal to the 1. अब इसको equal to 1 किया तो 3.162 is equal to omega square, is equal to omega root over omega square plus 9. Omega g के लिए magnitude equal to 1. Magnitude equal to the 1. Okay. So कितना हो गया? Let's take up the square. 3.162 square is equal to omega square. Under root को हटाने के लिए I take up the square. So what is the square for this one? Okay, so 9.99, that is nearly 10. So 10 is equal to omega. Simple करते हैं. Let us first of all put omega square equal to x. So 10 is equal to x into x square plus 9x, or you have x square plus 9x minus 10 equal to 0. It can be factorized easily. X plus of 10, x minus of 1 equal to 0. Correct hai? So x is equal to minus 10 ya plus 1. But what is the value for x? X is square of omega, so it should be positive. Right. So what is the x, which is omega g square? It should be 1. So what is the value of omega g? 1. It should not be minus 10. Square cannot be negative. हाँ, for diploma बहुत basic question आता है कृष्णा. You just have to go through basic formulas and all. This much will not be there for diploma. Okay, so omega g equal to the 1. Omega g is equal to the 1. Now we need the phase margin. So what is the magnitude? What is the angle here? What is the angle expression? निकाल देंगे ना. So what is the angle gj omega? Is numerator 0, then minus 90 minus tan inverse omega by 3. Minus 90 minus tan inverse omega by 3, and then phase margin will be 180 degree plus angle gj omega g. 180 degree plus angle gj omega g, and that is equal to 180 degree plus minus 90 minus tan inverse omega g. What is the value of omega g? 1 by 3. Just complete the calculation. Answer is there in front of you. Okay, केवल इसको complete करेंगे, आंसर आ जाएगा. This is 71.56. The phase margin of the system is 71.56 degree. Simple question. Okay, 71.56 degree. ठीक है, that's it. The phase margin. Okay, so these are the different varieties of questions. Some precautions, as I told you with the last question once again, कि whenever there is no real gain crossover frequency, phase margin infinity ले लेंगे. Omega p infinity, then also the gain margin will be infinity, diving case में. And if omega p is 0, starting angle is the omega p, then don't trust the GM formula. 2-3 precautions, rest all the basic formula based questions. Okay. So guys, that's it for the class, and that polar plot case also I will check. Okay, that's it for the class. So 4 sessions were allotted to me for control system in this GATE AIMERS class. So I have taken polar plot, Nyquist plot, Bode plots, and gain and phase margin. I think next subject will be yes, Srinath, we'll plan for that. I'll actually plan a marathon for signals. So these, rather than these small discrete sessions, we'll plan a continuous marathon. Next subject I think will be digital. You check the date exactly. Digital will be taken by Chandan sir, so you can attend that after this. Some important sessions of digital then. After that, one more session I have for you if you are interested into the practice of vector calculus. Okay, if you are interested into the practice of the vector calculus, so I have that session for you. That is a marathon session where I am planning 31 expected and 31 important questions all together. 31 most important questions of the vector calculus we are planning, and that is going to happen on the Saturday. Okay, I'll update about that. Yeah, lots of batches are going on, Krishna. Okay, for GATE also, for SSC JEE also, you can just look into the app. So there is a session. Yeah, Sangeeta will plan for APTI also. So right now, vector calculus, important 31 most expected questions covering up divergence, curl, gradient properties, covering up the line surface volume integral, and covering up the theorems. Okay, most expected questions in one single session. 7 p.m. Saturday. Same time we will follow. Tomorrow 7 p.m. I have the antenna class. Okay, that is on the Hindi channel. Tomorrow 7 p.m. antenna class is there on the Hindi channel. In this channel 7 p.m. Saturday we have the vector calculus session. Okay, that will be nearly 2 hours, you can say, around. Okay, Saturday को 7 p.m. देखते हैं. Okay guys, bye bye, thank you, stay safe, take care.